The Challenger did not explode because there were no warnings. It exploded after those warnings were debated. Engineers had raised concerns. The risks were discussed. The launch went ahead anyway. 73 seconds later, the shuttle broke apart over the Atlantic. What followed was not just a technical failure. It was a failure of judgment. January 28, 1986. Cape Canaveral, Florida. The morning air was unusually cold. Ice had formed along the launch structure. It was colder than any previous shuttle launch. Millions of Americans were watching live. Among the crew was Krista McAuliffe, a schoolteacher selected to inspire a nation. Across the country, classrooms had televisions turned on. Students were waiting. NASA needed this launch to proceed. Delays had already accumulated. The shuttle schedule was under pressure. Political pressure, operational pressure, public expectation, and beneath all of that, engineering concern. The night before launch, engineers from Morton Thiokol requested a teleconference. They were worried about one component, the O-rings, rubber seals inside the solid rocket boosters. In normal temperatures, they sealed properly. In extreme cold, they could lose elasticity. That night, forecasts predicted freezing conditions. The expected temperature at launch, 36 degrees Fahrenheit. It would be the coldest launch in shuttle history. No shuttle had ever launched under similar conditions. The concern was not theoretical. Previous flights had already shown O-ring erosion. In multiple missions, the primary seal had been damaged. Each time, the secondary seal had held. Each time, the mission was declared successful, but the pattern was visible. One engineer, Roger Boysterly, was direct. The data suggests we should not launch below 53 degrees. Charts were presented. Past damage was reviewed. Temperature correlations were discussed. The engineers recommended delay. The discussion continued for hours. Engineers repeated their concerns. NASA managers asked for stronger proof. Then came the question, where is your data proving it will fail? It was not a question about safety. It was a question about certainty. The burden shifted. Instead of proving it was unsafe, the engineers were asked to prove it would explode. NASA representatives stepped off the call. Thiokol management remained on the line. What followed was not a discussion about physics. It was a discussion about responsibility. In a closed executive caucus, the recommendation was reconsidered. When the call resumed, the final statement was delivered. We recommend launch. The engineers sat silent. It was no longer a technical debate. It was a management decision. January 28th, 11:38 a.m. The countdown reached 0. Challenger lifted into a clear blue sky. For 73 seconds, everything appeared normal. Then, a plume of flame. Cold temperatures had compromised the O-ring seal. Hot gases escaped the booster joint. Structural failure followed. The shuttle disintegrated in front of a live national audience. 7 astronauts were lost, including a teacher whose students were watching. In the investigation that followed, physicist Richard Feynman demonstrated the problem. He placed a sample of O-ring material into ice water. When removed, it failed to return to its original shape. Cold reduced elasticity. The seal could not respond fast enough. Under launch pressure, it was a simple physical reality. But the technical cause was not the full story, because the risk had already been known. The Challenger disaster became a case study. In organizational decision-making, investigators identified several forces: schedule pressure, normalization of deviance, groupthink, communication breakdown. Previous O-ring damage had not caused catastrophe, so it became tolerated. Risk thresholds shifted. Warning signs became routine. Engineers had data. Management had deadlines. And in high-stakes institutions, deadlines often speak louder than doubt. The Rogers Commission concluded NASA's decision-making process was flawed. The launch should not have proceeded. The disaster reshaped NASA's safety culture, but the lesson extended far beyond spaceflight. It became a warning about leadership, about how intelligent people inside high-pressure systems can convince themselves that risk is manageable. The Challenger did not explode in silence. It exploded after a discussion. And that distinction changed how history remembers it.